Hi, all. I welcome you to the Building Culture podcast, where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, or hobbyists, it does not matter. As long as you're someone who is passionate about building, I'll find you and podcast you. And in today's episode, we have a very special guest who is currently an expert mechanical design engineer at Miso Robotics, which is a startup based in Los Angeles, California. He did his master's in advanced manufacturing and design from MIT, the real MIT, and he did his bachelor's in manufacturing process and automation from NSIT. So I know him from NSIT. He was my college senior there, and we have done uh, some really nice projects together. I know him to be someone who is really passionate about mechanical engineering, a really inspirational person, and yet humble in his nature. So, without any further ado, let's welcome Abhimanyu Singh Bhakuni. So, my very first question to you is why Baha? So, just to give a little background regarding it, so SAE Baja is a student organized competition where students from various colleges participate and build an off road vehicle. So, this was probably the very first project that you did in your college. So, could you tell us about why you chose to do a project in your college and how the experience was?
Sure. Thank you for having me, first of all. Uh, Looking forward to this conversation. So why Baja? That brings back a lot of memories from undergrad. So coming into the college, I was kind of interested in understanding the applications of physics and math in tackling real world problems. Uh, Designing an all terrain vehicle, which is what NSIT Motorsports, the Baja team, it sounded like an amazing opportunity to understand how to design a system subjected to a lot of harsh and unknown conditions. A Baja vehicle is subjected to a lot of like crazy harsh conditions. And at that time, when I heard about the club NSIT Motorsports, I think it was the only club that was recruiting at that time, and I decided to give the interview, and then I got selected, which was kind of cool. Uh, in addition to that, I found that the team was divided into different departments, and every department, uh, for instance, like the chassis design or the transmission design, every department had some aspect which fascinated me. And getting an opportunity to work on an engineering problem so early in my college life seemed to me like a really valuable opportunity to bridge the gap between the classroom knowledge that I was gaining and the real world applications of it. So at that point of time, I remember I had started studying topics like engineering mechanics, strength of materials, and manufacturing processes, like the basics of that. And I found it like a really cool opportunity to just bring it all under one sphere and learn as I proceed in my college life. That was basically the reason why I decided to choose an engineering project so early in my college life.
So basically, that gave you a practical aspect of the engineering, the
Yeah,
theoretical things, the theoretical subjects that you were studying simultaneously.
yeah, yep.
So yeah, and specifically in Baja, you were in the design team. You were into mechanical design, and you were quite dedicatedly making models on SolidWorks. So uh, was it a choice of your own to go into the mechanical design department, or was it the one that was available? For example, there was a position there, a requirement there. Was it because of a vacancy that you chose mechanical design, or was there some aspect of it that motivated you to pursue this particular
Uh,
department?
so it's been a while, but as far as I can remember, there was this sort of an induction in which we were told about the different departments, and um, the team captain at that time explained to us what different departments do. And based on that, I found that the mechanical design department, to be specific, the chassis design department, I found it really interesting because the chassis had to do with all these beams and deflections and weight optimization and things like that. And those were some things that I was also studying uh, in my classroom, like engineering mechanics and like strength of materials, for instance. So I found that this could be a great opportunity to like gain some real life understanding of how these things work. That was why I chose to work on the chassis design, for instance. At that point of time, I did not know a lot about CAD modeling and things like that, but it was really early when I joined the team that I got an opportunity to use SolidWorks for building these models. And that was a great experience because I found that particular software or that particular concept to be really powerful. You were able to do a lot of things without even building the real thing. And that idea itself felt really powerful to me, and that kind of motivated the things in the future that I also participated in.
Yeah, that's quite interesting. But so that was your first mechanical design involvement, or the first kind of project that you did in mechanical design. And after that, I think it's at least 7 or 8 years that you have been in the same field now. So you are a mechanical design engineer at where you work right now, right? So
Yeah.
how do you think you have evolved as a mechanical design engineer over a period of 7 or 8 years?
Okay. So I think you're involving some years in the college as well in that experience, which would
Yeah.
be, I think, 4 years. Um, yeah. So I think what I felt as I've gained more experience is that there is this intuition that you gain over a point of time, especially in mechanical engineering. Uh, that intuition is basically about how a part behaves or a product behaves within a given set of boundary conditions. I think that can only come with experience when you get to do a lot of hands-on on a project and you learn from your mistakes. That is one thing that I've felt that has become stronger. The intuition part, you don't have to think about basic things anymore, which kind of helps in reducing the initial time it takes you to reach a first iteration of a prototype, for instance. Then the other thing is the ability. Like I feel that I've gained an ability to understand how people interact with things. That is something that I did not really think about um, early in my experiences with design projects. Uh, that is a really crucial element, especially for the things that I work on. It's very important to understand how people will use the product that you design. Is it safe to use, and is it reliable? Will people enjoy it? Is it ergonomic and things like that? So that is one thing that I put a lot of emphasis on when I'm thinking about my designs. And then this is something not really technical, but I feel that with time I've also realized the importance of planning for a mechanical engineer, because things like lead times, they are real. And for a mechanical engineer, being a mechanical engineer, you have to respect the supply chain that you are going to create or affect through your designs, and you have to take into account all those aspects as well when you are designing something. So you need to keep in mind that the way you design a component or a product can impact deadlines, can impact other stakeholders, and things like those things, which are not really on the technical side, but they're more on the operations front, for instance, or a little bit on the management side. So that's kind of how I would describe my evolution. It's like, in addition to technical stuff, I've also gained a lot of like practical and stuff related to humans and people. Uh,
Okay.
yeah.
Yeah. So essentially, I think what you're trying to say is that over these years of working on multiple projects, now you have become a more intuitive mechanical engineer. So, I mean, as you do more projects, as you get hold of multiple mechanical objects in your journey, then you kind of become more intuitive in your decisions. Sense of intuition that you have developed, that would mean that you would save a lot of time performing calculations, which probably you did a lot during the initial phase.
Yeah,
And yeah, so and the other thing that you're talking about is thinking from a usability point of view. When you are working on a project on your own as a student, you don't really care about that. You just want to you
yeah,
know get it done. You want to build it, and you are more process oriented and not thinking about how it will be used by the customer. And the
yeah,
third thing that you talk about, I think, is related to professionalism and uh, the operations part of it. How uh, so that thing that you're talking about is more related to project management, if I'm not mistaken, and less
yeah.
related to the actual design aspects, right?
Yes, that is correct. Yep.
Okay, so with this, I'll just come to the next question, which is what is the most interesting project that you have ever worked on over your, duration of experience?
Hmm. It's a good question. What comes to my mind is something which I did relatively recently in grad school, which is I took a course which was called Precision Product Design, and in that project I was we every student was tasked to make their own desktop lathe machine from scratch. So there was a lot of emphasis on deterministic design and how to develop this habit of testing small ideas before building the final thing, and then uh, having faith or having confidence in the engineering principles that you learn during the course, and then apply them to the building of your desktop lathe machine. The thing that I found really good about that particular project is not only the technical things that, as I talked about, but you also had to think about how to procure the material. How do I plan this in a way that by the time the material gets here, I'm ready to put it on the lathe machine or put it on the milling machine and start manufacturing it, and those kind of things. And the 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 most important part was you never sway away from the core of engineering in the project. You are always basing every decision on the engineering analysis and the calculations that you do, and the focus is always on doing the analysis, learning from the analysis, then building a small prototype to test that particular design parameter or functional requirement of the project, and learning from the prototype that you build and collecting data to see, is your analysis correct, and then if it's not correct, then improving it further to the point that you can say with a certain amount of confidence that now if I implement it in the final product, it is going to give me the desired performance. And doing it continuously over a period of time throughout the course. And then once you finally build the lathe machine, you can predict a lot of things about that lathe machine just based on the analysis that you did and improved over the course of time.
Yeah, so you specifically talk about how your experience was at MIT, basically. So
Yeah.
so I forgot to mention that you also worked as a mechanical engineer at Maruti Suzuki for 2 years.
Uh-huh.
And so now you have experience working solely, I mean, individually on the college projects at NSIT, and then working professionally at Maruti Suzuki. which is a big company, and then working, doing your projects at MIT, and then now working at Miso Robotics. So there are two comparisons that come to my mind right now. So first is comparing the institutes, the universities, for example, NSIT and MIT, and how courses are structured, and the way that you do projects, the approach, like you mentioned, with the precision project you talked
Yeah.
about this, and then about the approach working at a big company and then working at a startup. So I mean, that's a lot of stuff, and just take it one by one. So first, let's talk about your experience doing projects at MIT and how it was different as compared to NSIT, for say.
um, so um, when I started my grad school at MIT, I was kind of intimidated in the beginning. Just there are so many, like, you're always surrounded by really smart people, but at the same time, you get a lot of opportunities to learn from them and collaborate with them on solving challenging problems.
Mhm.
Um, it does not feel that easy in the beginning, but as you spend more time, you start getting more comfortable. Uh, what I felt at MIT is that there is a lot of focus on hands-on learning. Almost every course has a project component in which you are supposed to get your hands dirty and apply what you learned in the classroom to the real world. For instance, there was one course I took uh, in which uh, we had to make like remote controlled cars from scratch in a team, so using different manufacturing processes. So that was a part of a course which taught about manufacturing processes. So after learning about different manufacturing processes, we were expected to apply all that like knowledge uh, in a project, and then we were supposed to race those RC cards with other teams to test their performance. So that was one of my first experiences of like how classroom knowledge goes hand in hand with the real world hands-on learning. Then I already told you about the precision product design class, in which again we were learning a lot of stuff in the classroom, and then we had to like apply all that in building our own thing. So again, a building component there as well. And then even I took a management class, like a class about engineering management, and even that class had a component of uh, like a project component in which you were supposed to make a B plan in a team. So even in the management class, you were expected to put your learnings to the test in a real world scenario and face uh, people who will scrutinize your idea, who will scrutinize your B plan, and you can have to answer them based on what you have learned while making the B plan. And then you're also working in a team, so you have to also deal with team dynamics and things like that. So it's a pretty holistic approach to learning in general. And like the idea of hand in mind, mind in hand, which is basically the motto of MIT, is reflected in every aspect of the experience that you gain there. In comparison to that, during my undergrad, I felt like this is all in retrospect, obviously, because once
Mm.
you gain another experience, you can then reflect upon what you did in the past. I think most of the focus still is on like just the classroom knowledge, the knowledge that you gain in the class through books. And there is you still there is still an attempt to bridge that through lab work and labs, but I feel that that is still relatively a more controlled environment in which you can validate some things, but not like all the other uncertain or unexpected things that come your way in a real world environment. So there, like, for me and also for you, that we kind of tried to bridge that through the engineering projects that we did,
Mm.
which was totally in an uncontrolled sort of an environment, like really dynamic. stuff happening and things like that. So I think that's the big difference, is like not everyone gets an opportunity to participate
Yeah.
in projects like that. I mean, things are changing now. I see a lot many like competitions and events similar to Baja or the Formula SAE and things like that. But yeah, it's still like we still need to focus on like changing the culture itself, and the approach, in my opinion.
Mm-hmm. Yeah, interesting that you talk about the difference in not just the way education is approached, but also a general cultural difference, if I can put it that way, and the
Yeah.
motto of mind and hand, which you, as you mentioned, is ingrained in people there, and into the way the things are taught, as there is a practical component to all of the courses, even the management ones that you talk about. So also, what do you think is the general so whenever you are at a place, there's a general vibe about it, right? The environment about it, and
Yeah.
so what was the kind of environment that you uh, perceived at MIT? What was the mindset of the people there, and were they really motivated and excited to be building things and doing projects, or were they focusing more on getting good grades, focusing on scoring the top marks, as is always the mindset, or was it of both? I'm just curious about the way the mindset of the people there is.
So I think people are really focused on solving challenging problems in general. That is what I observed. Like without any exception, everyone is trying to solve some sort of a problem, and in really creative and like novel ways. That is something that I constantly witnessed there. I think there is not a lot of focus on grades at MIT, and also even if they are important, like the way the courses are structured, you always have this practical component and project component,
Yeah.
and a lot of people seem to enjoy that. At least it's what I observed. So even if you're not attending classes or you're not like super sincere that way, you can kind of offset that by like being good or performing well in the project part. And like the overall focus is to make sure that you learn and you are capable, you become capable enough to not be intimidated by challenging problems, and always like um, having the courage to face like problems which no one has solved before, and then come up with innovative ways, and like having this desire to always like um, figure out what's not working out, and making sure that you provide an elegant solution in the end.
Mhm. Yeah, that's interesting. I mean, you brought us to MIT for a couple of minutes, I would say. So yeah, so that's a really interesting way. That's a really nice way to explain the culture of MIT, and the way everyone approaches it, the enthusiasm that everyone shares regarding projects, and I mean, of course, uh, related to grades as well. But then you get grades for projects as well, right? So
Yeah, I mean, I think grades like don't really have a lot of value if you do not complement them with real life experiences and
yeah,
learnings.
certainly.
Um, like what I feel is good grades, they do communicate your diligence and sincerity towards gaining knowledge. Like if you're getting good grades, you're probably sincere, and you're doing like things diligently. But then, uh, so, but then you still like kind of need to. It's not the only thing that will ensure
Yeah,
that you will be successful in the real world.
yeah,
Uh, but it's kind of how it is perceived in our education system, unfortunately. Um, if you have good grades, it probably means that you are good at acquiring knowledge. So it might help in convincing like a recruiter or the admission committee of a college that if they do pick you, you will you will be spending less effort in learning new things.
yeah.
So and that's probably true only when you don't have a lot of hands-on experience. So uh, that's where grades might give you some benefit. But then I think one thing that working on real life projects does to you is to allow yourself to grow, uh, and do that by making mistakes or failing. But sadly, failing is not an option when you when you consider grades. So that's kind of the difference between real life and grades. In real life, you can still learn by making mistakes, and like in terms of grades, it's not that great, I think.
Yeah, yeah, yeah. And you have been notorious for doing well in both the areas. So you were also the topper. I don't know your grades at MIT, but at NSIT at least I know that you were the topper. Plus you were doing lots of projects. Like I think you did at least three projects. I don't know for
Yeah, I
sure.
think so. Three
Yeah.
or four.
So
I was
how?
not the topper, to be honest. To be clear, I was not the topper.
I mean, second or third would also be the topper for me, right?
Okay.
So, how did you manage these two aspects, like the grades and the project part? Because it's really challenging because I was also involved in projects, and then you have to compromise on something there.
Yeah.
So,
Yeah, I think one of the compromises was sleep.
certain.
I think you just have to keep working hard, to make sure that like things are making progress.
Mhm.
Uh, of course, you will have to make sacrifices. That goes without saying, because there is a lot you are trying to achieve in such a small span of time. I think what happened in my cases was most of the stuff that I was doing, I was also learning in the classroom. So, like machine design, for instance, like we were
Yeah.
studying that in the classroom, and then I was trying to implement that in the car, or in the hybrid trike that I made, and like the additive manufacturing that we studied, or the modern methods of manufacturing that I studied, was kind of related to the final project, like the thesis project that I did. So, I mean, you can make an effort to be smart about your decisions and choose something that kind of
Mhm.
complements what you're learning in the classroom. But yeah, in the end, you have to spend time
Yeah,
doing these
definitely.
things.
I mean, definitely working hard would be really important. And I mean, if you're really passionate about it, then it doesn't really bother you as well, right? If you're
Yeah.
working, putting in the hours, it wouldn't matter. And interesting that you talk about sleep, and I recall the previous conversation that we had, few days ago, and then you were talking about how you slept how you did not sleep at all for 36 hours or something.
Yeah.
Tell us about that.
Uh, this was also related to the that's why it's one of my favorite projects. This is related to the machine, like precision machine design class. That was not the only class I was taking. The
Yeah.
course that I did, the program that I did at MIT, is a really intense, fast paced, and challenging program. You are expected to do a lot of stuff in a short span of time and perform decently. So the precision machine design class has a lot of components to it. You have to first build something every week. You're expected to learn a new concept, and then make a module, or design and build a module and test it to close the loop. Then you have to document all that. In addition to that, there is an exercise called Seek and Geek, in which in which you have to explore things around you and figure out like how does this mechanism work, what might be the engineering calculations going behind this mechanism, and you have to like analyze that. You have to do your own calculations and document that as well. And then in the end, there is obviously the component of building the thing. So you have to go to the lab, buy material, manufacture it using like things like that. So this was more towards the completion of the course, when we were supposed to like create a full report in which uh, you had to tell about your journey during the project, how you did what you did, and what were the shortcomings, what did you learn, and things like that. And there, in addition to the deadline for that class or that course, I also had deadlines for other courses. So as I said, if you have a lot to do, then you have to spend time on it. So maybe like one thing that I could have done differently was to choose the courses in a way that they were kind of related, but in this case they were very different courses, like a course on supply chain, then a course heavy on machine design, and like some other courses. So
Mm-hmm.
that is when I had to like push myself. I would
Okay.
still say it's not a lot, but I would not recommend anyone to do anything like that. It's just it's not healthy. So just
Mhm.
plan it out and don't stress too much. Don't feel too pressured. You always work in it. You most of the times you work in a team or like you have a peer group. So just take their help, talk to them. Yeah.
So you're telling us how intensive the curriculum, the structure of the course that you took was. So were there also students who took more time than necessary to finish the course, or was that not an option, or everyone was finishing on time? So the course was for 1 year, right?
Yes.
So everyone had to graduate in the time span, or you could take longer. How was the opportunity for others to manage stress? For example, some people would like to take it a bit slower, right?
So ideally, in like like as per the expectation, you are required to complete the program in a year. But I do know people who took one more semester just because they wanted to explore more, and they had some very specific, I would say, goals that they thought were only possible if they spend one more semester, like doing things that they were planning to do. So I would say 95% of the people uh, did their program on time, and I think the like one or two people they decided to like give it one more semester to really like make sure that it could help them achieve their goals, I think.
But that was also because they wanted to explore more related to a project, for example, and not because they were not able to handle the pressure.
No, I think that was more because they wanted to like explore more. Yeah.
Oh,
And
okay.
they had really genuine and really strong reasons to extend it for one more semester. Yeah.
Okay. So yeah, I can imagine how challenging it must be, but then it was worth it at the end, right?
I
Yeah.
think, yeah.
So now I'll try to, go a bit more technical. So given a design problem, for example, building a lawnmower from scratch, how do you approach it? What are the steps that you take? Yeah, what is your way of going about a project when given a problem statement, for example?
Hmm. Okay. Um, so I usually start by laying down the functional requirements of any product or any part or any component that I'm like tasked to design. This is one of the methodologies I learned in the precision design class. It's called Fred Park, which is like an abbreviation for like for a given set of steps that you have to take. So the first step is to start with the functional requirements, lay down everything that your product has to uh, every requirement your product has to satisfy in order to be in order to be successful. So for instance, for a lawnmower, one of the functional requirements is could be that it cuts the grass.
Yeah.
It's like something as simple as that. Functional requirements can be relatively simple, like in terms of their definition, or like a human should be able to push it, or something like that, or it should be powered by an electric source of energy, or something,
Mhm.
electrical source of energy. So you do that, and then for every functional requirement, you assign different design parameters. Design parameter is something that you will have to uh, like put into the design to make sure that the function can be met. So, for example, one design parameter could be that the lawnmower has like the to cut the grass, the lawnmower should be able to have a blade that like applies uh, a specific amount of shear force to shear the grass off, or maybe another
Mhm.
design. So this is one way using which you can cut the grass. Maybe another way could be you like pull the grass so that you like just remove like take it off the ground, something like that.
Mhm.
So then for that design parameter, I do like an engineering analysis. So maybe I will calculate the shear force required to cut the grass, or I will calculate how much torque do I really need to cut the grass, or something like that.
Yeah.
Um, Going ahead, I will like based I will use my analysis and my knowledge, but then I will also refer some like resources that already like have that can already support my analysis. That's like the references part. And then I will try to list down some of the risks associated with different design parameters, just to see that is this the right way to go. Like for example, shearing versus pulling, I will
Yeah.
like list down risks associated with both of them, and then I'll come up with countermeasures. And based on this analysis, I should be able to pick one or two design parameter for each functional requirement, and then I will try to incorporate that into my design. So this is more of like the technical way to go about like a design process, which I follow. In addition to that, something that I started doing recently is doing something called the riskiest assumption tests. Uh, just to give you a context, the usual way in which a product is designed, or like the early stage design works, is there is a thing called the minimum viable prototype, the MVP. The
Mhm.
idea is that what is the minimum viable thing that I can build to prove that this thing, like the final product that I'm imagining, is going to work, right?
The
uh,
concept works.
that the concept works, so like proof of concept or
Yeah.
something. So that kind of follows the methodology of build, measure, and then learn. So you build something, then you put that into test, and then you measure what's happening, and then you learn that, okay, I thought this will perform a particular way, but it is not. So you
Mhm.
learn from it. The riskiest assumption test, on the other hand, does it the opposite way, which is you learn first about the problem, then you measure some stuff about that problem using really small tests focused on a particular assumption. And once you have done your learning and measuring loop, you finally build something based on these learnings. So the idea is that if I'm building something, I will always have some assumptions.
Yeah.
Uh, and if I spend a lot of like, if I allocate a lot of resources and capital to build that product, without realizing that one of the assumptions was fundamentally wrong,
Mhm.
there is no point of the minimum viable product to exist, because one of the assumptions were fundamentally wrong, and I spent so much time and resources on and money on that particular product. So the idea is to reduce that expenditure of a lot of things and
Mhm.
try to test small things first, and then move on to the final product. So that way, when you build the final product and someone questions you why you made it this way, you can go and explain that this is because I evaluated all these assumptions and I came up with these results, and that is why I finally made it the way I made it. It works pretty good in a startup environment, especially for like mechanical engineering in general for a startup, because we are kind of like always balancing our time, efforts, and funds. So you don't really want to spend a lot of time and money on things which don't make it to the final product. So it helps you to do it in a very frugal way, do small tests in a very frugal way, and
Mhm.
then go to the final thing. So that is something I have started doing recently, and it helps out a lot.
Yeah, it definitely sounds a more practical way to go about it, because then
Yeah.
you save the cost and the time of actually building something that might not
Yes.
be useful.
Yeah.
Yeah. So also, can you give an example using application of this learn, measure, and build thing, considering, for example, the lawnmower example or any other, simple example, like what would be the assumptions that have in the beginning, and if you learn those things and measure them and understand them before building it, it saves a lot of uh, cost, time, and energy.
I
So
think like for the lawnmower thing, it can be something as simple as um, like just building a very small setup of a blade essentially, and then testing out like how much torque is actually required to cut a piece of grass, or like cut different types of grasses, instead of building an entire lawnmower prototype and then realizing that, oh no, like this cannot. Because what happens is, once you build something, making changes in that finally, like the fully built product is in general a little more expensive and time
yeah.
consuming than doing these small experiments. So like something like you just need you just need a small setup in which you can mount a motor of your choice, and then uh, like design small blades, and then try to use different grass types and or things like that to
Mhm.
see how that performs. And once you have this knowledge well documented, all you have to do is to like choose the right thing uh, and implement it in your final product.
Okay, that's a really nice example. You made the whole process very clear of how to approach a design problem. You also explained the Fred Park approach, which is taught by Professor Alex Slocum, right? And
Yeah.
I've seen some of his lectures online, and he has a really different and eccentric way of teaching things, but also interesting, because he kind of cracks jokes and makes funny gestures during his lectures, if we can even call them lectures. And then if you his desk, and there are lots of mechanical gadgets and just equipments that you
Yeah.
can get a feel of, and become a better mechanical design engineer. So the question that I want to ask you is, how does your desk look like? How does your working desk look like? Are you more uh, towards the creative side of design or the analytical side of design? And or I mean, you need both the phases, right? So do you also organize your desk according to which phase of the project you are, or is it always clean?
It's definitely not always clean. Usually there are a decent amount of cables
Yeah.
lying here and there and things like that. But I usually have like a big screen on my desk, which I use to like do all the CAD work, essentially all the like during the design phase. And then usually when I'm thinking about stuff, I tend to keep my desk a little decluttered. I clean up as much as possible because for some reason I am distracted by things that I see on my desk. So I just either I would clean my desk, or if it's not possible, I would just go into another room uh, where there is no one. I'm just sitting alone, and that helps me focus.
Yeah.
But then if I'm doing prototyping, which I usually am, so let's say I'm doing a lot of 3D printing, I'm cutting a lot of metal, and I'm building structures and things like that. So at that point of time, like right now I'm working from home, obviously, but in the office, at that point of time, my desk is usually like filled with these 3D printed prototypes and things like that. Yeah. And then
Yeah.
I usually, like at my home, I usually tend to keep like one or two projects that I'm working on my desk, and then some books. Like
Okay.
for example, I have this book, The History of Strength of Materials by Timoshenko. I should be reading more of this, but like for example, this is one of the books I have on my desk these days. This is just to like I started. This was recommended to me by a friend. This just speaks about how strength of materials evolved over time, and it talks about how people in the past used to think about things and what kind of math or physics were they doing. They made a lot of assumptions, and like we do as well. But how things have evolved, and we have our analysis has become more closer to reality, basically. So this kind of gives you a sense of like how people are always striving to improve and make things better, basically.
Yeah. So, really fascinating how you bring up the whole process and how you have these books surrounding you and you read them on a regular basis to be inspired by these things. Because if we think about it, then a book that's dedicated to the history of strength of material is not really helpful in your work, not directly, but it serves as a motivation for you
Yeah.
to, do a better uh, job. So what inspires you to, uh, work hard at mechanical design, and what is that thing that pushes you every day at work, for example?
Hmm. I haven't really thought a lot about it, but I think I think it's for me. I think it's just the curiosity to know what lies behind the problem I'm trying to solve. That's I mean, maybe it's just me, but I think that's the only thing. And then at the same time, it's like the desire to reach the solution of a problem and kind of uncover the the mystery of what it actually was, and then of course like to learn from it, to learn from the mistakes that I make through the process. I can only learn and make mistakes if I keep working and if I'm consistent with what I'm doing, which is also a way to improve yourself over time. So I think the like I there has to be a goal in your mind, but to achieve that goal you have to make like a constant effort to improve yourself,
Yeah.
and working hard allows me to make mistakes as soon as quickly as possible, which allows me to get better as fast as possible. And at the same time it helps to like feed my curiosity to know what exactly is going on. uh, it's basically it. And then recently, or not really recently, but like after doing all the engineering projects, I also like it the feeling you get after spending a lot of time on something, and building it with your hands, and then allowing other people to use it, review it, get feedbacks, and they can be happy about it, they can be sad about it, but that process itself kind of gets you like, or at least me, it gets me emotionally attached to the thing that I'm working on. And that feeling is it's hard to like explain that feeling, but uh, after one point of time, like you're probably doing it just to get that feeling again and again. It's
Oh.
a really good feeling, to be honest.
So you are hooked onto the process, if that's an
Kind
appropriate
of.
word. It. Yeah.
Yeah.
Is it also safe to say that for you it's the process is more important, and for you it's like a game, because then when you do a project, then you in a way level up and you gain new skills, and then you can take harder challenges to solve.
I think you can say it that way. I think that's a good way to put it. It's a so game in general is something that is challenging, but at the same time you enjoy it.
Yeah.
So you have a good time like solving the problems. And I think yes, it is kind of like a game. Although like gamification is something that people think is like simplifying a lot of things, and like
Yeah.
not to confuse it with gamification. But yeah, I mean, the more you become comfortable with the process, the more you feel that it is in your control, and the more it is in your control, which is basically like, and if you have some sort of autonomy associated with what you do, that definitely makes it a more enjoyable process. And
Yeah.
then once you close the loop and you see the results, it that's the biggest gain in confidence that you can have, in my opinion. And yeah, it keeps getting better, in my opinion. Yeah.
Yeah, yeah. So, admittedly, this gamification analogy was a bit too much, but I guess the point that I was trying to make. So you love the process so much, and you kind of always grow out of it, which is a great thing.
Yeah.
So yeah. So now I think it's time to move to the question that we kind of left in the early stage of the conversation. So we have compared the work culture at NSIT and MIT, for example, and now if you could compare the difference uh, in attitude or approach, how a project is approached, and the responsibilities that you have in working at a big company and then also working at a startup. So my assumption is that you really enjoy your work. It's not my assumption. I mean, we have talked enough to understand that you really love your job here. So, what is the difference then, like between the two kinds of
Hmm.
organization structures and
Yeah, so I have worked in both of them, as you said. So early in my career, I worked for like the biggest car company in India,
yeah,
Maruti Suzuki. I worked in R&D, and there I think what I observed, and it's a no-brainer, that in a big company the culture and the processes are pretty well established,
yeah,
uh, which which is kind of related to the fact that there is already a set mindset, or like a well-formed mindset of doing things in a certain way.
hmm,
So so and of course, because you come into that culture, you are also taught or trained to be a part of that culture, to adapt that culture, and to try to think in a way that uh, everyone is used to thinking, which I found is, like, at least in my case, they caused or um, in some cases things can take a little bit longer to happen, because like the systems are so well established in the field. It takes a lot of approvals to finally implement a change or introduce something like new. So a lot of work that happens in like big companies, or I would say a big chunk, is to just improve the existing things. But the processes are so well established that it's a relatively more time consuming process, and the risks are obviously pretty high, because every
yeah,
change impacts so many stakeholders. The supply chains are well established. The marketing and sales channels are well established, and all those things are affected. So you have to be really like careful and get approval from everyone before making the change. Uh, the other thing is that the big companies, they have a lot of funds at their disposal, so they can invest a lot in R&D. Like they can set up labs, they can have like really like modern testing facilities. They can outsource a lot of work, they can afford to do that. uh, which brings me to the startup uh, kind of way of doing things. uh, in a startup, you're usually trying to do all of this, like the research and development work, with limited funds. So you have to come up with like frugal ways, as I said in the past, of doing research and development. You still have to figure out how do I solve this problem, but because you're kind of limited on funds, you have to think wisely before spending money. You have to come up with different approaches to solve like a challenging problem. In addition to that, I think in a startup, the culture is still being figured out. So everyone is trying to figure out what's the best way of doing things. The processes are still being established. Of course, there are a lot of people who have a lot of expertise, so they have very good insights and inputs about how to do things the right way. But we are still figuring that out. So you can still try to make sure that you have your inputs being taken into consideration as everyone is forming a culture. Everyone has a pretty open mindset of doing things. Like people do not limit themselves to a specific or a certain set of doing things just because like not a lot of things are well established. Not a lot of stakeholders are involved. So people are still open to like trying out new things. There is a lot of scope for innovation and creativity,
Mhm.
because like the entire team is trying to figure out what the right product is, and what aspects are still like a little fuzzy. What do we have to figure out next and things like that. So you can be a little more creative and innovative to push your ideas through. And then um, the impact that you cause, at least what I have observed, is a little more visible compared to
Yeah.
what you do in a big company. So it has happened with me, that I made some concepts and made some like product renders, these like nice looking pictures of like the future of kitchen automation and things like that. And
Mhm.
like 2 or 3 weeks after that, I see those pictures appearing in news articles
Oh,
and like conferences and all that. And it is impact, but you still have to think about the fact that it can go one way or the other. So with the opportunity to create impact, there is also a sense of responsibility that you have to take into account. And then like sometimes you make a product or a prototype, and like a week after you see that in some news article, and it gives you it brings a sense of pride. Of course it makes you feel happy and proud, but at the same time, as I said, it also forces you to think about what you're doing and do it the right way, so
yeah.
that the impact is positive. um, it's pretty hectic, it's pretty fast. uh, you have to know your stuff decently well to do things. Changes are expensive, and most of the times you can't really afford to have them. So the attempt at doing things like it's it's a mixture of things. So you're still figuring out a lot of things, but when you like have to spend money, there is a lot of consideration given on doing it the right way in the first attempt. So that's kind of like the differences I've observed. uh,
Yeah.
yeah.
So to summarize it, with great power comes great responsibility, right?
Something like that.
Yeah, so you definitely have a lot more challenges here because there are so many unsolved problems, not just related to product, but also as other aspects, other areas, and you also have the chance to contribute to a variety of different areas. For example, you would be also actively involved in the production part of it. Uh,
Yeah. Yeah.
yeah, so the challenging part, the fact that you have more challenges, then it gives you more responsibility and a chance to meaningfully contribute to the organization, which would be
Yeah.
really impossible in a big company because then you are just a small cogwheel in a big system in a company like that.
It just takes more time, in my opinion.
Yeah, yeah, yeah.
Uh, yeah. So
So you see your impact more quickly here. That's a huge.
that's what I have experienced. Yes.
Yeah. So silly that I didn't ask you what Miso Robotics is before I, asked you to come to a startup and an established
Yeah.
company. But I think, I mean, of course, I know it. But for the sake of the people who are watching, could you please give an idea of what Miso Robotics is? You just mentioned that you're building the future of kitchens. So what are what are a few of your major products and who are your customers? What is your company about? So
So Miso Robotics is a company that builds smart robots for kitchens. Basically, the idea is to combine robotics and artificial intelligence and apply that in a kitchen environment, commercial kitchens to be specific. Um, there are a lot of things that happen in a kitchen related to cooking that are very repetitive. People don't want to do those things.
Yeah.
There, people, but there is still a lot of time and effort that goes into uh, uh, giving the people those skills to do those things. But then people leave. So, so like for example, one of the things is frying food. That's not the most desirable job uh, someone wants to do in a kitchen, but at the same time that process is so repetitive that there is a big scope for automating something like that. So what our system does is uh, it is capable of using or looking at the food and identifying what that food type is, and then manipulating that food in a kitchen space so that you can have sort of like a cold to cooked kind of a workflow in which you start with cold uncooked food. The system identifies that, then it brings it to the cooking equipment, be it a fryer or a grill or something like that, and then it is able to track how long it takes to cook, and then finally it delivers it at the output where a human can take it out and serve it to the customers.
Yeah.
So that's basically what we do. We have a few customers. I can't speak a lot on that front, but we have a few systems deployed in baseball stadiums. One in Los Angeles, one in Phoenix, Arizona, and then we have a couple of systems deployed in restaurants locally here in Los Angeles and also in Florida.
Okay. Yeah. So it's fascinating how, you are, how a process like, it would be hard to imagine for a lot of people that a conventional process of, for example, frying a patty for a burger, for instance, can be totally done by a robot and automated in on, on a commercial scale, but maybe later all on also for household
Yeah.
equipments. So also, just to get more idea, so is it a collaborative robot that you're using, or is it a robot in a fence? So would the kitchen area be isolated from the human, or the human would also be engaging with the robot? What's the product like?
So the nature of interaction is collaborative. Um, although right now we are using an arm that is more on the industrial side, um, but we still like safety is the highest priority in a kitchen, both food safety and user safety. So we make sure that human interaction is done through some safety interfaces like safety scanners and things like that. And uh, it is not essentially a cell in which you have gates and entry points and things like that, but it is designed in a way that you don't feel that you're working in a factory around industrial robots, but at the same time you are safe working around them because you have all the safety interfaces in place.
Yeah, so you kind of have both of these aspects, the safety aspect, but at the same time it's a collaborative robot, right?
Technically it's not a collaborative robot at this stage, but the nature of interaction collab can still be classified under collaborative, I think.
Okay, okay. And so for a product like this, a robotic, it would be a robotic arm, I assume. And so for a product like this, there goes a lot of different aspects. Like for example, you mentioned it has to identify the cold product first, and then it has to manipulate it. It has to pick it up and then put it into a frying pan. So the manipulation and movement part of it, the kinematic aspect of it, and then uh, the safety aspect of it. So there is a lot of stuff going
Yeah.
around. I mean, could you also give a view of the different departments that are involved? So you are, for example, in mechanical design. I'm assuming there must be a machine learning guy who is
Yeah.
feeding lots of data and I don't know if there's a separate computer vision division or the machine learning people are doing it, and what are the other, I mean, who are the stakeholders involved in building a typical product at Miso Robotics?
Yeah, so it's a pretty amazing like interdisciplinary team that we have at Miso. You have mechanical engineers working on like building the stuff around the robot and all the interfaces, making things look good. Then we have software engineers who make sure that like the software runs efficiently and things like that. We have robotics engineers who work with the robot on behaviors, on manipulation. Then, of course, we have machine learning engineers who figure out the environment, looking at food types, looking at equipment. Um, we have scheduling people related to who work on the scheduler to figure out what's the best way or the most efficient or quickest way to cook food when you're presented with different food types, to figure out all that. Um, and then you have people who help out with deploying the system on the field. Then you have people doing analytics, people doing product design, user interface. There's a
Yeah.
lot going on. Then operations, to make sure that things get into the field smoothly, uh, customers are happy, clients are satisfied, and so there's a lot going on. Yeah.
Yeah. So yeah, that's and how big is your team, if I may ask?
I think it's close to 25 people. So
Just
there are a
25
lot of people. So
people.
there are a lot of people who do who perform different roles. I can give you my example.
Yeah.
uh, uh, so I am a mechanical engineer here at Miso. Just to give you some context, I came to Miso as an intern after my grad school, and then I helped the team improve their component designs or part designs to make them more scalable, like for manufacturing. So I did a lot of engineering analysis, design optimization, design for manufacturing during my intern days. And then I've worked a lot of things. I've worked on a lot of things after I joined full time. So my role is primarily an R&D role, focusing on exploring like new opportunities in automation in the kitchen space. So that's my kind of primary role, I would say. But in addition to that, as I was explaining earlier, I have worked on making these early stage concept designs and like making these nice looking product renders. Um, Probably for what you will need a graphic designer essentially
Okay.
to so so I've done a little bit of that, and then I do a lot of prototyping. We I also do testing, which in the ideal world would require like a dedicated test engineer. um, then I do like uh, engineering analysis on component level and the system level to ensure that things are safe and reliable. I also participate actively in the design for manufacturing exercises to ensure the product is easy to build and it costs reasonable and things like that. So even and this is true for the other mechanical engineers as well. So
Yeah.
like working in a startup in a small team, you kind of have to wear different hats as required with time, and that kind of gives you a sense of, although there are 25 people in the company, there are probably like 35 to 40 roles they're they're serving. So that's why it's a little surprising when you explain what all teams are there, what all people do. But
Yeah.
then when you tell people the team size, they're usually surprised. But yeah, that's why I said it's very hectic and fast paced and challenging.
Yeah. So the interesting that just 25 people have so many responsibilities, as you mentioned, that you yourself have multiple roles, and
Yes,
the conventional mechanical design and mechanical engineering production and all those things too, also rendering the things and what probably
exactly.
a stylist would be doing in a bigger company.
Yeah.
So, but also this is probably one of the things that you like about working in a startup, right? So,
Yeah,
brings me to the
totally.
question: what is the most important? So, what is the thing that you enjoy the most about working here at Miso Robotics?
Um, I think just closely working with uh, people with interdisciplinary skills, uh, because that allows me to expand my horizon of thinking. Essentially, like everyone has a certain way of thinking, because I come from a mechanical engineering background, so I have like like a mindset of thinking about things uh, from the viewpoint of mechanisms, and if,
Yeah,
whether it will be weak, or I don't want it to break, or I don't want it to bend. Uh, should not be heavy and things like that. But then there are other aspects, like is the user even going to touch this thing, or like this thing looks too intimidating, or I need to make sure that it looks good. um, the robot itself, the way it is controlled, affects how I have to design everything around it. Will it interfere with something? Will it collide? What will happen then? What is the reason we want the robot to be oriented in a particular way? That has to deal with some concerns from the robotics
yeah,
team and things like that. So in a very short span of time and in a very small group, you are still able to understand so many different aspects that go into making the final product. Is something that I really enjoy. It's I would not say it is easy. Communication is a really important part, and it's a really crucial component of working in a startup. You everyone, because like not me but the other people are so smart, but that they are
come on.
like everyone thinks in their own like space, but the idea should always be to bring it together, and so that it is presented to everyone, and everyone has a buy-in. So communication is a very important part, but I think it it it, it happens very well in Miso, and that is, I think, the most enjoyable part, is to work with so many people with so many different skill sets.
Yeah. So it can be overwhelming at times as well, but the diversity makes it an enriching experience in a way, because you get,
Yes.
you get to be around people who think differently. So you kind of get a mindset of thinking about a product in a more holistic way, which is a huge
Yes.
advantage of working at a startup.
Yeah.
That's interesting. So, breaking the flow of this, going deep into your work. Now, I'd just like to, go a bit casual. So,
Okay.
what is it? So, you are in Los Angeles, California, right? Uh,
Yes.
so, what is the environment like?
Uh, in general, Los Angeles has great weather. It
Yeah.
has it probably has everything in a radius of 1 to 2 hours. By everything I mean, you can go to the beach. It takes you around 45 minutes to reach the beach.
Mhm.
Then at a distance of, I would say, 1 to 2 hours away, you have mountains with like snow-capped mountains. You have national parks around. The weather in general is very pleasant. It gets hot in summers, but it never snows, so it's pretty pleasant. Um, and then I felt that it's a relatively more laid back environment compared to a place like the Bay Area, San Francisco. People are a little bit more chilled out, uh, and then yeah, in general, it's a really beautiful place. I really like it. Where I live in Pasadena, where also the campus of Caltech is. It's really close to the mountains, and I really like mountains. So every time I get out of my house, like just a walk of 5 minutes, and I'm able to see the entire San Gabriel Valley and the range, the mountain range, which is a pretty beautiful sight. So Yeah, and it still has a tech culture. It is growing. There are a lot of companies being set up in Santa Monica, which is also in Los Angeles, and yeah, so it has a nice tech culture, but it is also like a very like chill sort of a place. Or
Okay,
yeah,
so, yeah. Apart from the work, I mean, your work at Miso Robotics, you also have other opportunities to enjoy there because you can go to the mountains and explore the areas and have some fun around as well. So
yeah.
that's nice. So
There are a lot of engineering colleges, universities around. Like you have UCLA very close. Caltech is right. Like it's like 15 minutes from where I live. And you have USC uh, 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 around 40 minutes from here. So there's a nice culture that exists as far as the tech space is concerned.
so there must be quite a few startups in that area as well, right?
Yeah, there are a lot of startups in this area.
Okay, interesting place to live in, I would say.
Yeah, it's pretty fun.
Now I'd like to go a bit more personal into how you think and what inspires you a bit. Also a bit. I'll be touching a bit of philosophical side if I can say that. And so yeah. So what? Who is your role model? I mean, you must definitely have. Some role models who inspire you or some of the people who you look up to, for example, some it may be some people in mechanical engineering or just any person in general, or is it that you don't believe in role models and you are just focused on working? What is your mindset when it comes to mentorship and all those things?
Hmm. Okay, so I'll be honest in saying that I don't really have a role model like like one specific person who I want to be like. Uh, Although I always try to learn from people who have been successful in doing what they do. I always try to surround myself with people who I want to learn from, who I'm inspired by. Uh, I I really feel motivated around my friends. I mean, I'm really fortunate to be associated with them. They're really smart people.
Yeah.
Uh, so yeah, I mean the the attempt that I always try to make is to learn from people who are good at what they do, and to just learn from like just learn what they do, like what they do differently, which makes them so successful in their
Mhm.
respective fields. So yeah, uh, as far as the importance of mentorship is concerned, I think having a good mentor is really important, in my opinion. Uh, I mean, a good mentor will always act as a catalyst to your professional growth, but will still give you the opportunity to make mistakes and explore your own ideas.
Mhm.
Uh, uh, this is essentially what I feel about having a like a mentor. Um, I have been fortunate to be surrounded by people who I can also call as my mentors in one way or the other. Uh, but yeah, a good mentor will always give you the space you want to explore, but at the same time will alert you if you're doing something really absurd or if you're
Yeah.
thinking of doing something really crazy, because a mentor has usually has way more experience than you, and they have a good judgment about a lot of things that you are still trying to like grow.
Mhm.
Yeah,
Uh,
that's what I think.
Yeah, because in a field like mechanical engineering,
Yeah,
experience matters a lot, right?
it matters a
So,
lot.
who
Yeah.
has worked for 10 years, 15 years, you can definitely, learn his way of approaching a problem, approaching different challenges because he has worked on more problems. So, his experience definitely can be learned by someone who is just, starting. And of course, the idea of mentorship that you talk about that you treat all the people that you're surrounded with as mentors in a way. So you're surrounded by a tribe of mentors, if I can say that.
Sure.
Yeah. So talking about these things, inspiration, mentorship, and role models, learning from other people. Uh, do you think books play a role in shaping your mindset in a field like mechanical engineering? So, what are the books that have had the most impact on you? You just showed me the history of strength of materials book. I'm sure that that's just for inspiration. But is there one book or a few books that really changed the course of your life, or have had a meaningful impact on the way you think?
Um, so I really liked the book about Steve Jobs by Walter Isaacson. I learned a lot about the way Steve Jobs used to think about things. Um, I'm not big on reading, I'll be honest. Uh, but yeah, that was one of the books that just like that book just tells you a lot about the person he was, and how he looked at things, and how he just he was so consistent with his pursuit of excellence, I would say,
Yeah,
like pursuit of
exactly.
perfection or excellence. He was just obsessed about it. And so after a point of time, it gets really hard to like justify that sort of obsession, uh, like like being so obsessive that you're also concerned about how the electronic circuit boards look for your product is like just another
Yeah.
level of obsession. So but then at the same time, he always tried to um blend uh, art with design and technology, which I find kind of cool about Steve Jobs. And he was uh, pretty consistent, as I said, about pushing the boundaries and not being intimidated by any challenge that came his way. That's kind of a way of living, if you think about it, and that is something that I would like to inculcate in myself as well, is to like not be intimidated by any challenge that comes my way, always striving to achieve the best that possibly can be achieved. uh, and then the other book I read, not very recently, but still like a year ago, was The Design of Everyday Things by Don Norman. That
Mm-hmm.
basically talks about the psychology associated with interacting with products, and how the design of things around you uh, affects your emotions, affects the things that uh, that you perceive when you look at a product. Like what defines a good product, what defines a bad product. And it's most of the times it is not the fault of the user, that the user is not able to figure out why something is not working out. It is the fault of the designer, because the designer did not make it in a way that was able to communicate what a particular product is capable of doing. So that actually helped me a lot in thinking about my designs in a very different way. That's more of like a human centric or a human centered design philosophy that came to me. Like I was not really into it a lot, uh, I would say. But after reading that book, I started being even more conscious about my designs and the things that I'm making. So now, whenever I'm designing something that involves interaction with a human, I'm always trying to think of ways to make it or design it or build it in a way that is very that is very easy to use or interact, essentially. So I mean, I think these are the two books that recently uh, that come to my mind, basically, if I think about like what they changed in me.
So interesting that you talk about these two different aspects of the two books that have had an impact on you. So one is you talked about Steve Jobs and his personality. So the two traits that you probably want to inculcate in you, that the one that you talked about was his obsession and his attention to detail. For example, uh, having control over all aspects of a product, from thinking of a product from an artistic point of view as well. You talked about beautiful looking electronic boards, for instance, right? And then also about the engineering sophistication of it. So that's like the one part of Steve Jobs, and the other part would be his courage of not dreaming less, so dreaming big and taking really big challenges, engineering challenges, or general business related challenges, I should say. So is it also safe to say that you want to inculcate this kind of obsession? Because I'm pretty sure you already have a certain level of obsession when it comes to working, for example.
Yeah, I mean, more than the obsession, I would say, uh, like having, like building the courage to tackle any challenge that comes your way is something that I would inculcate. I would want to inculcate more compared to just the obsession. Or you can kind of, like, if you work on something for a long period of time, you, as I said, you get emotionally attached to it, and that kind of translates to obsession, in my opinion. So
Yeah.
that's kind of what will eventually what might eventually happen. But I think what I can consciously make an effort to make better is to build the ability to take challenges without getting intimidated.
Yeah, that's really fascinating how you are taking the aspects of Steve Jobs that you would want in your life, because he was also a complicated person. If so, and also you talked about the other aspect of it. So this was the personality aspect of the inspiration, and then the other part was that you actually took something and implemented it in your way of working or way of designing things. So which you talked about design of everyday things, and uh, that a product should be user friendly, and there's no stupid customer, there's just a stupid designer. If I have to put it right way. Yeah. So then I also read this book, or I listened to this the audiobook few years ago, and the one thing that I can remember now is that doors are a poor design. It,
Yeah. A lot of them, like,
they
they
mention,
have a name called Norman doors.
yeah, exactly. So could you tell us more about that? Because that's against the grain. Nobody thinks about doors. It's standard, right?
Yeah,
The same kinds of doors. So why are doors a bad design?
doors, like, I would not say that, like, doors in general are badly designed, but the thing is that there are a few basic things that, like, if you're designing a door, you have to, like, keep in mind. For example, a door can be like a push type of a door, or a pull
Yeah.
type, or a slider. Let's say there are three types. So if you're making a door that is supposed to be pushed, essentially, and if you put a handle on it, the handle itself communicates that it is something to be pulled and not pushed.
Makes
uh,
sense.
so what happens is, as soon as someone sees a handle, they have a tendency to pull it, and if it's a door designed to be pushed, it's nothing's going to happen. But eventually you will realize that, yes, you have to hold the handle and push it. But that is not the best way to communicate that. A better way to communicate something for a push type of a door is to, let's say, put a metal, like just a metal plate on the door. uh, so now you don't have anything that you can pull on, right? So
Yeah.
all you can do is to try and, like, that metal plate is just an indicator of where to put your hand, for instance, and the only thing you can do to it is to push, basically. And then it's kind of the same thing goes with sliding doors, which are even more complicated, because you can't really tell by looking at a door if it is sliding type, because if you look at a door, you don't really look to your surroundings as to see what kind of a door it is. So for a sliding door, it is a little more complicated. Like if you put a handle on a sliding door, you will first have a tendency to pull it. That's not going to work out. Then you will try to push it, which is like probably the second natural reaction. That's not going to work out. Then you will be like perplexed for a while that why is it not working out. But in the end you will figure it out that okay, it is a sliding door, but you could have probably given like a feature or maybe like just an arrow. Putting symbols to communicate how a thing works is also not the best way to do it. The
Yeah.
design itself should incorporate some element which leaves you no option than to push on that door. So I mean, yeah. So that's kind of the thing about doors. It's a very simple thing. We all kind of take doors for granted,
Yeah.
and but there are some nuances that you can even like you can use to even improve the door design. Uh, and there are a lot of badly designed doors, of course. So
Yeah, so the idea is to make the design stupid simple for the user. So
yeah,
there's no possibility of pulling it when there's no handle, and so it's obvious
yeah,
that you will be pushing it. So that's like a really simple idea, but at the same time really fascinating also, because we don't really think about doors. And in a lot of the doors we have these push and pull levers.
exactly.
So and you just said that they are not the best way to, design a product. If that means that you didn't spend time on design thinking and thinking about the customer. So you have to put the labels. That's you have to in a way specify a manual of using a door, and
Yeah.
that's not a good way to
It
go
is,
about.
yeah. Another thing that it does is like every user, when the user interacts with the product, there is a mental model that forms in your head about how this thing works. And in the at the same time, there is also an like a conceptual or an engineering model that the designer like designed it to. So usually what happens is a good product for a good product, the mental model matches the engineering model, and it works as you think in your head. But in badly designed products, what happens is the mental model is nowhere matching to the conceptual model, and that's why you expect something to happen, but in reality, something totally different is happening behind the scenes, and you are never able to figure out why something is going wrong. Like one of the example he gives is of a refrigerator, and there are two compartments. One is the normal refrigerator part, and then the freezer essentially. So there are knobs inside the freezer and the refrigerator to control the temperature.
Yeah.
What you like for a particular brand, I don't know what brand it is, and even he does not mention that, but for a particular brand the refrigerator was designed in a way that both the temperature of both the compartments were linked together. So if you want to lower the temperature of the refrigerator part, the temperature of the freezer will have to compensate for that. It will lose some of the temperature, but despite that, you have temperature knobs on both, like temperature levels on both the things. So if imagine someone trying to figure out like, hey, I tried to make my normal compartment cooler, but what that did was it made my freezer temperature rise. And why is that happening? There are two different knobs. So the engineer knows what's going behind in the conceptual model, but what the user is thinking is that both compartments are independently controlled because you put two knobs, and that's the only logical way to think about it from a common sense uh, kind of a
Yeah.
way. So, and that's probably a very good example of how when conceptual model does not match the mental model, bad product experiences happen. So
Yeah, that's a really new way to of thinking about design, because You talked about matching the mental model with the model that you actually use for
Yeah,
design, which is a different way of approaching design, and not a different way. Probably I was not familiar about this way of thinking, but
yeah,
also I think it really gives a glimpse of the challenges that are involved when you are making a product from scratch, because then you have to imagine everything, nothing exists, and then you have to imagine how it will be used by one set of customers, different set of customers, the different environments
yeah.
it might have to perform. So that's a really challenging thing, and that's also probably one of the reasons that uh, you partake in it with so much enthusiasm, because uh, there's some level of fun involved in solving
Yeah.
problems, which
Um,
mechanical design, you know,
yeah.
gives you lots of opportunities for.
Yeah. Another important aspect of this is conducting user studies. Um, so you make a product and you invite some users, and then all you do is to provide them some instructions about what this is, very basic instructions. You don't like tell them a lot of stuff about the product, and then all you do is to let them interact with the product. You give them a task that, hey, I want you to do this, use this product to achieve that goal, and you just observe them. And sometimes what happens is like something that you designed by putting so much effort and like so much thinking, what you observe is they are not even looking at that particular aspect, like they're not even paying attention to that. And that is when you realize that, oh, okay, this is not really the most important part of the problem. So like user testing and taking feedback from real users is a pretty important part of improving your overall design. And that is something that I've like started appreciating even more after I joined Miso, because people
Mhm.
working in the kitchens are not really used to working with robots, right? So
Definitely.
it's a pretty new thing for them. And then once you start doing these user studies, you get to learn a lot of how people perceive the robot. Sometimes some people can have certain preconceived notions about robots. It's
Yeah.
like they can harm people, they are intimidating and things like that. So then you have to take all those things into mind as into your like consideration while designing everything.
Yeah, so it is a process that can get as complicated as you want it to,
Yeah,
and as simple as you keep it,
yeah.
actually.
The idea in the end revolves a lot around like just plain common sense.
Yeah,
Even if you read the design of everyday things, most of the things that Don Norman talks about, you will be really surprised that wait, why is he talking about this? This is so like
obvious.
obvious.
Yeah,
But if you reflect upon the things that we do as engineers, you will realize that I've done this a lot of times, and it seems to be common sense, but it just does not come to your head when it needs to.
yeah. So common sense is not common practice in a way.
Sure. Yeah.
Yeah. Finally, I'd just like to ask you for your suggestions, advice, or tips for anyone who wants to, have a really interesting career which he enjoys in mechanical design or mechanical engineering, or probably any engineering field in general. So, what are your suggestions?
um, I think just don't be afraid to make mistakes. I mean, books teach you what you should do, uh,
Yeah.
but it's hard to find books that tell you what not to do. So don't be afraid to fail. What the books don't teach you is like what happens when you fail, and like how to even derive learnings from like a failed experience or a failed attempt. That's a big one that I have like you are not encouraged to fail. in most of the cases, at least like in our families, failure is not really looked at with great eyes. But
Yeah.
I think being comfortable with failure is okay. Uh, there is no point putting extra stress on yourself, um, because that what that does is it just leads you to tunnel vision, and then you're just not able to think uh,
Mhm.
about a lot of things. What happens in most of cases, in my opinion, is we think about a lot of things in our head, and most of them we reject, just thinking that, oh, it's going to fail and it's going to look awful when it fails and things like that. Just don't do that. A lot of that also has to do with the environment you are in. So always strive to surround yourself with people
Mhm.
who are open to failures, who have a pretty open mindset about things, and who just don't do things in one particular way. Um, Methods and processes are very important, but there is like a fine line between too stuck with a particular way of doing things. So always stay on the other side of that line. Uh, Respect methods, respect processes, but just don't uh, confine yourself to that. Yeah. And then try to gain like good real life experiences, either through internships or design projects. um, Always try to like close the loop of any design project that you're working on, any design problem that you're trying to solve. Once you
Yeah.
go through the entire process and close the loop, the wealth of knowledge that you gain from that one loop itself is immense. And that kind of gets you into the habit of making things better. And if you do that multiple times, then you just get into the habit of making things better and always trying to uh, improve upon what you already did. So
Yeah. So essentially, taking up more projects, more experiences, and trying new things, getting your hands dirty, not being afraid
yeah.
of failures, all these things, so that you take up more projects and you learn more along the way, and also challenging the standards that are already established, so that maybe you come up with a new way of approaching the problem, which is probably one of the major lessons from your startup, right?
Yeah. And
Yeah.
then
So
always try to learn and understand the other aspects of making a product successful than just your particular domain.
yeah.
That involves working in a cross-functional team with other people from other domains of expertise, uh, and things like that. So just try to understand the other aspects of design. It will just uh, make your like just make your thinking more broad, essentially, and you will be able to respect and appreciate all the other efforts that go into making a product successful.
Yeah, yeah, this is like not just engineering advice, but good advice, good success advice in general. So, I mean, I would also definitely take your advice into account and implement it whenever I can.
Thank
So,
you.
with this, I'd just like to thank you, sir, for all this information, the abundance of knowledge that you shared today, and it was really helpful and meaningful to have an interaction with you. It was enriching to have uh, understood your way of thinking, your experiences, the enthusiasm that you have for this particular field, and it was definitely a very enriching experience. I'm looking forward to having another conversation with you in the future, maybe.
Yeah, let's do it. Yeah,
Thank
it
you.
was really fun talking to you. I really liked the questions that you were asking. They took me back in in time. But
That
yeah,
was
it was really good talking to you. Yeah.
Hi, all. I welcome you to the Building Culture podcast, where I invite incredibly smart people who build things.